This lesson is on infinite limits. A limit goes to infinity when the function approaches a vertical asymptote from one side or the other or both. So let's look at an example. We have a function f of x equals 8 over x minus 5. Little graph of the function. You see the function has a vertical asymptote at x equals 5. From the left side, the function approaches negative infinity. From the right side, the function approaches positive infinity. If you look at a table of values, a numerical approach, we know that at x equals 5, the function is undefined. In order to be an asymptote, in order to be a vertical asymptote, a rational function has to have a denominator equal to 0. So we know at x equals 5, this denominator will equal 0. We look here, we pick 4.9, 4.99, 4.999. We get closer and closer to 5 from the left. The numbers go infinitely small. Negative 80, negative 800, negative 8,000. As we get closer and closer to 5 from the right side, the numbers get infinitely large. So therefore, the limits from those sides go to infinity or negative infinity. Infinite limits graphically, to make this formal. Here's a function. The limit of f of x as x approaches c. From the left side, the function is going to positive infinity. From the right side, the function is going to positive infinity. So we can say that the limit is infinity. Over here, from the left side, we're going to negative infinity. From the right side, we're going to negative infinity. So we can say that the limit of that function is going to negative infinity. I know in the past, we defined limits that went to an asymptote as they do not exist. You said that the limit does not exist. This is another way to say it. If they both go to the same infinity, they both go infinitely low or both go infinitely high, you can say they go to positive or negative infinity. Over here, you have a function where the limit from the left goes to positive infinity, the limit from the right goes to negative infinity. There's no other way to say this limit other than it does not exist. You have to talk a little bit about vertical asymptotes because some problems will try to trick you. A vertical asymptote occurs in a rational function when the denominator is 0 and the numerator is not 0. So if you plug in a value into a rational function and you get some number, 15 over 0, negative 800 over 0, 3,000 over 0, 2.2 over 0, some number over 0, then that function has a vertical asymptote at that value of x. If you plug in a number and you get 0 over 0, that is not a vertical asymptote. That is going to give you a hole in the graph. And I'm going to show you a couple of examples of how that happens. For a vertical asymptote, you want a number over 0, not 0 over 0. So we have this function here, f of x equals 5 over x squared minus 9. So we're going to need a little bit of factoring from algebra class. 5 over x plus 3, x minus 3. So you know that if x equals negative 3 and x equals positive 3, the denominator will equal 0. Well, neither of those numbers is going to turn 5 into a 0, so this is always going to be a number over 0. So this function, the graph of this function, would have two vertical asymptotes at x equals negative 3 and x equals positive 3. Now we go over here to this function. We have x minus 5 as a numerator, x squared minus 2x minus 15 as a denominator. We see this is a trinomial that can be factored. So you factor in x plus 3x minus 5. At x equals negative 3, this factor is equal to 0. If I plug in negative 3 on the top, I get negative 8 over 0 times negative 8. I get negative 8 over 0. So I have a vertical asymptote at negative 3. X minus 5. X equals positive 5 will give you a 0 in the denominator, but it will also give you a 0 in the numerator. These two terms cancel. That means at x equals 5, you would have a hole in the graph. So you would have a vertical asymptote at x equals negative 3, but you would only have a hole in the graph at x equals positive 5. So the limit as x approaches 5 for this function would actually have a value. Over here. This is a function where you can factor the top and the bottom, the numerator and the denominator. You factor them out, you see a common factor of x plus 1. So again, these two would cancel, so that x equals -1, the graph would have a hole, and at x equals +1, since there's no common factor of x minus 1 on top, you would have a vertical asymptote. So again, the function has to say a number over 0 for you to get a vertical asymptote. 0 over 0 with a factor, the same factor on the top and on the bottom, numerator and denominator, you would get a hole in the graph. Once you've determined that you have a vertical asymptote at a point, at an x value, then the limit as x approaches that value must either be infinity or negative infinity, or does not exist. It could be going to opposite ways. So, but as from the left, the limit has to equal infinity or negative infinity. From the right, the limit has to equal infinity or negative infinity. And overall, it depends. It could be both or neither. So for this function here, I know that x equals 3 is a vertical asymptote. So you look at the function and you want, as x approaches 3 from the left, from the negative side, you know that the numerator is always going to be positive. You know that x equals 3 is a vertical asymptote. So all you need to do is figure out, is the denominator going to be a positive number or a negative number? And that will determine whether you're going to positive infinity or negative infinity. Once you know it's going to infinity, you just have to figure out the sign. So if I take 3 from the left, I'm going to plug in like 2.9. Well, 2.9 plus 3 is going to be positive. 2.9 minus 3 is going to be a little bit negative. So this is going to be a positive number over a negative number. So from the left side, I know I'm going to infinity because it's an asymptote. And I know I'm going to negative infinity because it's a positive over a negative. Do the same thing from the right side. You plug in the 3.1, positive, positive. So I get positive over positive. So from the right side, I'm going to be going to positive infinity. So once you know it's a vertical asymptote, your left side and right side limits have to be infinity or negative infinity, and you just need to figure out the sign of the number. You don't need to figure out the actual value of 3.1 times -0.1 and try to figure out all that.